Hello, I'll present to you BPL++, a quality management and assurance support system. The Good Laboratory Practices, or GLP, consists of a set of principles intended to assure the quality and integrity of non-clinical studies. It covers the process and conditions under which non-clinical health and environmental studies are planned, performed, monitored, reported, and archived. GLP compliance facilitates the acceptance of data at both national and international levels in the context of regulatory processes, where authorities must assess the safety of new products. It focuses on maintaining all information related to laboratory processes, such as materials, reagents, test and reference substances, test systems, and standard operation procedures. It also maintains information on the equipment used and participating personnel. However, GLP compliance can be challenging. Although general recommendations of the GLP principles are simple as a concept and easy to read, their implementation and recognition of the compliance of a laboratory are complex. It may require a deep understanding of all laboratory procedures and how they can be adapted to GLP. Because of this, it is common for GLP deployment to be slow and costly, potentially requiring changes to laboratory routine and team training. The use of computational systems can help overcome the main problems found in such an approach, such as data overload, difficulties in data retrieval, reliability, and traceability. Laboratory Information Management Systems, or LIMS, are one tool that can assist in this task. LIMS are computer systems that manage experimental data. They store data from each experimental step, providing access to this data and also relating these steps. LIMS provide trackability of experiments, allowing users to identify which steps are related to which other steps, improving the quality of the experiments. BPL++ is a LIMS designed to assist in GLP compliance. It uses Flux, a workflow-based LIMS that allows experiments to be modeled in workflows, where each experimental step is a workflow activity. It is very flexible. Flux can manage different experiments by using different workflows. Moreover, designing workflows is easy and does not depend on modifying system code. Flux has been developed to manage biomedical data. It is used today to manage toxicity assays, nanotechnology experiments, proteomics experiments, and medical data, among others. It is easy to adapt to new experiments since new workflows can be easily developed. It has an easy-to-use web-based interface as well as a comprehensive security module. Access permission can be given for each activity independently, making it possible to control which users access which data. It also has an auditing module that ensures the consistency of the database as well as access security. In Flux, a workflow consists of a sequence of laboratory experiments, medical exams, or lab information sets. These are called activities. Each activity has attributes that define the data that needs to be stored. Those are fields in electronic forms. Examples of attributes include execution data, the exam results, equipment use, concentration of samples, and others. An example of a screenshot of Flux can be seen in this page, where you can see on the left side, on the left frame, you can see the set of activities that have been executed or that can be executed. In this case, just one activity can be executed. On the right frame, you can see the attributes of this activity. In this case, full name, birth date, nationality, and so on. Once these fields are filled and they have the appropriate values, we can submit this form, and this activity will show here as a green tube and can be accessed later. In this work, we present BPL++, a LIMS to assist in GLP compliance that has been developed using the Flux LIMS. Workflows that specify the data required by GLP have been developed. providing easy access to all pertinent data as well as trackability. To construct the workflows, we model the activities needed for each information set. In this example, we show the activities for the equipment workflow and the teams and responsibility one. We can see here for the equipment workflow, for example, that the first activity is a registration of the equipment and then the installation. Then you can verify their status, verify their condition, register the status, and then one important feature, you can register occurrences and the resolution of occurrences. So for example, if an equipment is down because it has generated an error, it can be registered here and then it can be searched for later, as well as the resolution of the occurrence. So it's easy to specify everything that has happened and all the solutions for the problems. Cleaning usage also can be registered this workflow. The teams and responsibility workflow registers the personal data of the personnel using of the lab. You can specify health and emergency information such as vaccination and phone numbers to call and things like that. And you can register academic education curriculum capabilities, so you can be sure that the appropriate personnel has the ability and the qualifications to use the equipment needed. And here we see one of the screenshots of the Flux workflow editor in which the workflow is created. We can just create activities and then register the activities attributes in this frame. Flux uses Java as the main programming language and Apache Tomcat as the web server and MySQL as the database server. In this, we can see that BPL++ has a number of workflows. It has 4 workflows: the equipment workflow, the teams and responsibility workflows, the test and reference item workflow, and the standard operating procedure workflow. The equipment workflow, it registers equipment management information used in the lab, such as installation, calibration, and cleaning. Using this workflow, it is possible to trace procedures performed on a particular equipment and occurrences or malfunction in such equipment. It is straightforward, for example, to determine which problems have not yet been corrected or when equipment operations such as cleaning or calibration are due. And here we see one screenshot of the workflow, of the equipment workflow, in which you can see the available activities. So in this case, the registration has been executed, it has a green tube, and the equipment has been installed, it also has a green tube. And we can then execute the verification, status, maintenance, and calibration activities. In this case, the equipment registration activity is selected, and the equipment registration information is shown on the right frame. The teams and responsibility workflow assists in the management of data from laboratory personnel and their responsibilities. It includes information on laboratory teams such as personal data, academic background, etc., as shown before. And here is a screenshot of the teams and responsibility workflow, where we can see the activities that relate to the workflow that has been shown. The test and reference item workflow manages information on test and reference items regarding receipt, handling, sampling, and storage. The standard operating procedure workflow ensures that there are appropriate and technically valid SOPs relevant to the activities being performed. And here we have one screenshot of the test and reference item workflow, where we can see in this activity, the attributes, we can see the data that has been received, the shipping details, delivery, who delivered it, who received it, and all other information. GLP compliance is an important quality assurance system. However, its implementation can be complex due to high costs of GLP assisting systems, modification of laboratory routine, and personal training. This work presents BPL++, a LIMS to assist laboratories in GLP compliance. It is user-friendly, based on web browsers, which allows access from anywhere and any device connected to the internet. BPL++ is a tool to allow collection of GLP-compliant laboratory data easily and efficiently, while maintaining trackability of the information, providing a low-cost system that enables registering all the GLP data in a simplified manner. Therefore, BPL++ has the potential to increase GLP compliance of laboratory without adding significantly to their expenses. BPL++ can be accessed using in this URL, and thank you very much for your attention.